Hi, and welcome to TV Science Program. My name is Vivian Lee, SB18032, and my partner, Muhammad Amirun, SB18018, will be joining us shortly. We are presenter from Group 2, and now I'm going to present about Bioremediation Assignment 2. The name of the case study that we've chosen is Water Quality Assessment of Tekala River, Selangor, Malaysia. First, background of the case study. Tekala River, Selangor, Malaysia is located 43 km from Kuala Lumpur City in the Hulu Langat area close to the Semenyih Dam. The reason Tekala River is chosen is because of its importance as a recreational area. Since it is a recreational river where many people will go for a picnic, it is critical that the river water quality protects the public from hazardous level of pathogens while engaging in water contact activities. The parameters in these studies are biochemical oxygen demand, chemical oxygen demand, ammoniacal nitrogen, total suspended solid, dissolved oxygen, pH, and total dissolved solid. Second, discussion and case study finding. In this topic, we'll be talking about comparison of Tekala River, Sungai Galing, and Tasik Gambang data. The sample in this study. The water sample were taken from the chosen river on 2 occasions, in May 2017 and October 2017. A total of 18 water samples were collected from 6 sampling locations along the river, and another 18 water samples were taken for the BOD samples. For the laboratory experiment, there are 2 water samples which were taken from Sungai Galing, SG, and Tasik Gambang, TG. Here is the data of the measurement of 7 experiments, including the case study measurement. Summary of Tekala River water quality. Based on the case finding of Tekala River, the water quality index was determined based on the physical, chemical, and biological parameters, which contain a total of 13 parameters. The water quality index for Tekala River will range from 85.845 to 94.86, thus indicate that the water quality status for both sampling times and 6 sampling stations are classified under Class 1 and Class 2. The data from the study was compared with the National Water Quality Standard, NWQS. Thus, the Tekala River is classified under Class 1 to Class 2B, implying that this river is safe to be used for recreational purpose. However, the authors recommend that further research on other parameters on this river to be conducted in order to get better assessment on the water quality. Summary of the SG and TG water quality. This experiment was to determine the water quality of Water Galing and Tasik Gambang. An experiment was conducted based on the physical chemical, which consists of 7 parameters using self-kit test. From the result, all of the parameters were classified under Class 3 and 5 when compared with the National Water Quality Standard, NWQS. This means that both of the water quality of SG and TG are heavily polluted. The water quality of TG, however, is less polluted when compared to SG. This might be because the SG river is connected by the river from industrial Semangbu area, which might be because of it. A poor water quality could pose a healthy risk for both ecosystem and humans. Thus, it needs a serious attention from concerned party to treat the water back to a healthy state. That's all from me. Next, I will pass to my partner, AMIRUN. Thank you.
Thank you, Vivian. Hello, Doctor. My name is Muhammad Amirun Beno, and I'm going to present about the conventional method of the case study and also the suggestion for the bioremediation methods to be used to treat the Tekala River, Selangor. So, the first conventional method is the biochemical oxygen demand, which is a technique to determine the total organic content in a sample which are available to the microbes and organisms involved in any spontaneous reaction, whether it be weeds, fish, and also algae that has the spontaneous reaction with the oxygen in a specific time, period, and specific temperature. So the value of the BOD is expressed in mg of oxygen consumed per liter, and the conventional method used by the order is the incubating the water sample for 5 days. The dissolved oxygen value DO is determined using the first reading before the incubation, termed as DO initial, and the second reading is after the incubation, which is termed as DO final. So the equation for the BOD value is BOD in milligram per liter equal to dissolved oxygen final minus dissolved oxygen initial before the incubation. The second method, conventional method, is the total suspended solid (TSS), which is a technique to measure the amount of solid in water that can be caught by a filter. The process is simple. Water sample is filtered to a pre-weighted filter. TSS is referred to as an increase in the filter weight. So conventional method of the case study is first, the filter paper with pore size of 0.45 micrometer is put in petri dish and dry in oven at temperature of 105 degrees Celsius for 1 to 2 hours. Afterward, the filter paper was taken out and cooled for 30 minutes. The filter paper will wait before filtration, and this will be the first reading of the sample. The filter paper will then used in the filtration process, where it is inserted between the Bushnell funnel and the suction flask. The water sample of the Tekala River is then passed through the filtration. The filter paper was then put back in petri dish and dried again at 105 degrees Celsius for 1 to 2 hours. And then the final weight of the filter paper was recorded. The third method, conventional method used in the assessment, is the ammoniacal nitrogen, which is a technique to measure the amount of ammonia in a water. Since ammonia is considered as toxic pollutant and can directly poison human body and damage the equilibrium water system in the body. So also the value of the ammoniacal nitrogen is in milligram per milliliter. The conventional method of the case study is as follows, which is the first 25 ml of deionized water and 25 ml of sample transferred into glass cell each. 3 drops of mineral stabilizer is added, and afterward 3 drops of polyvinyl alcohol is introduced. 1 ml of Nestle reagent were added to each transferred sample, and mixture was measured using spectrophotometer at 4 to 5 nanometer wavelength. For this spectrophotometer analysis, the blend used was the deionized water. The fourth conventional method used by the assessment is the chemical oxygen demand, which is a technique to estimate the amount of oxygen to be consumed by reactions in a given solution. This technique measures the amount of organic, nitrate, sulfide, salts, and other reducing chemicals in water. It is also can be expressed as mass of oxygen used divided by the volume of the solution in mg per ml. So the higher the chemical oxygen demand value, the more significant amount of oxidizable contaminant present in the surface water. So the conventional method used in the assessment is the reactor digestion method by USEPA. The sample is first homogenized to dissolve the containing solids. Afterward, the homogenized sample were added into glass vial with potassium dichromate as strong oxidizing agent. The mixture was then heated to 150 degrees Celsius for 2 hours, and the determination of the chemical oxygen demand is using the calorimetric method with height range of the DR/2010 instrument. So moving on to the suggestion of the bioremediation method. First, we need to see the stations and the major problems of the assessment. So in the case study, average water quality index term QI is found to be in class 1 and class 2. So for the remediation, only simple conventional method required to treat the water contamination. So the lowest water quality index of the study is at station 4, which is the value is 84.45. In general, the water quality index is expected to decrease in value from the upstream of the river, which is the station 1, to the downstream of the river, which is the station 6, due to increment of the pollutant. From the sixth station, station 4 has the highest contaminant and lower degradation rate compared to other stations. This is mainly due to the presence of the visitor of the recreational park at the station 4 uh, in station 4 to the station 6. In conclusion, station 4 to station 6 need a conventional treatment, where most important treatment is needed at the station 4. For the aerobic and anaerobic, the bioremediation method that are suitable for this problem is the aerobic and anaerobic bioremediation, which is the most important parameter to be treated from station 4 to station 6 is the ammonia level, because from the report study, there is a high value of ammonia concentration from station 4 to station 6. So a suitable biological process to remove nitrogen in the ammonia compound is using the nitrification and the denitrification process. The most common bacteria that can perform the ammonia oxidation process to be introduced in three stations of the Tekala River is mainly the Nitrosomonas species. In ammonia oxidation process, the bacteria accumulate ammonia or the nitrate in the river and use it as an electron acceptor, while the carbon source for the bacteria is the carbon dioxide. Uh, Also, in addition, Schmidt and Bock has proved that the aerobic nitrification process of the Nitrosomonas is not the only pathway available for the ammonia oxygen. And they also show that one species, Nitrosomonas eutropha, are able to oxidize ammonia present in the nitrate in an anaerobic condition. There are two important things to be included in the nitrification and denitrification process, which is the level of oxygen and carbon dioxide dissolved. So these two compound can be determined by the level of the dissolved oxygen, where both compounds are directly proportional. Meaning that if the level of oxygen dissolved is high, the carbon dioxide level of dissolved carbon dioxide will be also directly proportional to the oxygen. Although the dissolved oxygen level of the Tekala River are decreasing exponentially from the station 1 to station 6, the DO level is still high at high concentration and abundant for the various bacteria, especially the Nitrosomonas species, to perform the biological process. Hence, there is no need of any in situ biospalging or the bioventing process to be applied, to be additionally applied beforehand. So, since the Tekala River water quality index is at class 2, therefore there is no need for ex situ denitrification process, which is the denitrification process is further performed by the same Nitrosomonas at low rate, since there are quite available oxygen present in the water. So here are the reference of the presentation, and thank you, thank you, Doctor.